Measuring Trees from Outer Space. I'm Tonya Hall, and joining me is Dr. Paul Montesano, research scientist with SSAAI at NASA's Goddard Space Flight Center. Welcome, Dr. Montesano.
Hi, thanks for having me.
So, what does science systems and applications do, and how does it support the Goddard Space Flight Center?
Well, SSAI provides research scientists and other support staff to NASA. In my case, I'm a research scientist that focuses on landscape changes and forest structure, primarily in the boreal forest of North America and Eurasia. So I'm one of many scientists here that use Earth observation data to try to understand the Earth systems, their processes, and how these processes are changing and how humans are affecting these changing processes, and what might that mean for the future.
So as you described, your specialty is using satellites to measure trees from space, which is a really cool job. But what does satellite measurement of the world's forests offer that ground-based observations can't tell us?
Yeah, that's a good question. So really, we're interested in accounting for the distribution of carbon across the land's surface. You may have heard of the carbon cycle. You may understand that the carbon cycle is changing, and terrestrial vegetation is a big component of this carbon cycle, these carbon processes. And so really what we're interested in is to figure out ways to measure the current extent and patterns of vegetation carbon. Trees are a big part of that, across the landscape, and understand how these features, these trees, these forests, are changing over time. The most efficient way to do that is using satellite data. Satellites orbit the Earth, and they collect data across global extents. And so it gives us, using these data, we get this whole Earth picture of the characteristics of interest. In my case, it's forests. It's much more, it's the only way to do it. You can't collect enough ground measurements to get a real understanding of the details of these forests and the way that they're changing. So instead, we use satellite imagery at various scales to understand the details that we think can tell us how vegetation is influencing the carbon cycle, and how these vegetation characteristics are changing through time.
What is JEDI, and how are lasers used to measure forests?
Yeah, so lasers are an incredibly important tool for those of us trying to figure out and account for terrestrial carbon and the carbon that's stored in vegetation. So JEDI stands for the Global Ecosystems Dynamics Investigation, and it's a LiDAR instrument that has been launched, I believe it was launched in December, and started collecting data in March. It's mounted on the International Space Station, and it's different from a satellite that it doesn't collect data across the entire globe, but it's mounted on the space station, and it collects LiDAR data primarily in the temperate and tropical latitudes, below about 51 degrees north and above about 51 degrees south latitude. And it's a LiDAR instrument that shoots LiDAR beams from the instrument down towards Earth along predetermined tracks. And these LiDAR pulses, the time that the pulse takes to be transmitted from the sensor, hit the ground, and be received back in the sensor is measured, and that measurement is translated into a surface elevation. And that surface elevation can get translated into a height of certain features above the ground surface. And so these LiDAR instruments are an incredibly important tool for systematically measuring the height and the structure, the vertical and horizontal structure of forests on a global scale. And these LiDAR measurements are very, very precise. And with this precision, we're afforded the opportunity to understand the variation in forest heights across space, geographic space, and also the change in heights across time through repeat measurements with these LiDAR instruments.
What are other sensors besides lasers that we use?
So most people are familiar with NASA and the work that NASA does in space, looking outwards. NASA also has a variety of Earth observation platforms, satellites, that collect information about the terrestrial surface of the Earth, the surface of the oceans, the atmosphere, ice surfaces. So there are a variety of sensors and technologies that are used to collect all this really interesting information. I'd say people are most aware of NASA imagery. They've seen the pretty pictures of sort of maybe the GOES satellite, or maybe they're familiar with Landsat satellite data. Imagery is probably the most common form of satellite data. But people like me recently are really interested in coupling NASA satellite imagery or satellite imagery from other institutions or organizations, coupling satellite imagery with these LiDAR measurements that you mentioned earlier from the JEDI instrument, or from a recently launched NASA instrument called ISAT-2. And it's really the satellite technology combining or integrating a variety of these satellite technologies to measure different characteristics of the Earth's surface and the Earth's surface changes that are kind of really cutting edge, that interest me and that I've been kind of focusing my work on for a while.
What are ecotones, and why is it important to measure those?
So, yeah, that's a good question. So I have been focusing, the geographic scope that I'm interested in is the boreal forest. Boreal forests circle the northern hemisphere in the far north, in North America and Eurasia. Specifically, the specific portion of the boreal forest that I've been interested in is the ecotone that separates the boreal forest domain from the Arctic tundra domain in the far north. An ecotone is sort of a fancy way of saying an ecological transition zone. And this is a transition zone where that's described and acknowledged according to the transition of forest structure as you move from the warmer edge of the boreal forest to the colder edge of the boreal forest, or towards the tundra. An ecotone is a place where a variety of tundra and boreal species interact. And it's also a zone that is a little bit difficult to quantify, but it's fairly important in terms of being able to predict the fate of boreal and tundra landscapes that are seeing some fairly rapid changes in climate conditions in the last number of decades. So really an ecotone is a place, a broad zone, a sort of a diffuse zone, where we think it's important to really begin to refine our estimates of these forest characteristics which define the zone and which are understood to be changing.
You mentioned climate change. What are some of the best uses for the data that you're gathering?
So there are a lot of uses for the type of forest structure data that we collect and we work with, we analyze. Really, for me, I think one of the primary uses of the forest structure data that we're trying to collect from satellites, and again, what we're doing is we're trying to refine our estimates of the height of forests and the horizontal extent and cover of forest, particularly for me, particularly in the boreal and the boreal tundra ecotone domain, in order to get a handle on the patterns that the structure takes on, in order to understand the variability of this structure across North America and across Eurasia, in order to perhaps, and this is kind of some of the curiosities that we have these days, in order to perhaps be able to predict the fate of these forests at the edge of the northern boreal domain. So I think that it's what we're trying to do is we're trying to detect a relatively subtle signal of short and sparse trees at the northern edge of the boreal that coincide with rapidly changing ecological characteristics. We're trying to detect a subtle signal, and then we're trying to understand how these differences in these subtle signals across broad extents, what that might mean for trying to figure out how the boreal forest will change.
Dr. Paul Montesano, research scientist with SSAAI at NASA's Goddard Space Flight Center. If somebody wants to connect with you, maybe they want to find out more about this work that you're doing, how can they do that?
Well, I think the best way to connect with me personally is to email me, paul.m.montesano@nasa.gov. They can also check out earthobservatory.nasa.gov, which features a broad variety of examples of the earth science work that is done here at NASA Goddard Space Flight Center.
And thank you so much. And if you guys want to find me and more of my interviews, you can do that right here or go to tonyahall.net. Thanks for watching.